Think about a window for a second. It seems so simple, doesn't it? I mean, it's just a hole in the wall to let in some light. But what if I told you that simple hole was at the center of a fierce, century-long debate? A real battle between some of the greatest minds in art and architecture over its perfect shape and placement. So, in one corner, you've got the classic vertical window. It's tall, elegant, traditional, you know the type, you see it in Renaissance paintings. And in the other corner, you have the challenger, the ribbon window, this long horizontal strip of glass that became the symbol of a whole new, modern way of thinking. And believe me, this was never just about style. Oh no, this was a battle of philosophies. And that right there brings us to the Great Window Debate, a clash between tradition and modernity, art and science, feeling and function. And at the heart of it all is one very provocative claim from an absolute giant of architecture. And that giant was Le Corbusier. He was the champion of the ribbon window, and he was not shy about it at all. He confidently declared that his horizontal windows were just flat out better at lighting a room than those old-fashioned vertical ones. And he claimed he had the proof. Okay, so this is where it gets really interesting. Le Corbusier didn't just, rely on what he saw with his own eyes. No, he believed he had hard scientific evidence. He pointed to what he called explicit graphs taken from a photographer's sensitive film, claiming it objectively proved his point. The sensitive film had spoken. So here was his big argument. A ribbon window, he said, creates these two simple, huge zones of light. One very lit and one well lit. Easy. But two vertical windows? He claimed they create a total mess of 4 zones with these massive patches of poorly lit, even dark space. His big conclusion? You'd need 4 times less exposure to snap a photo in his room. Case closed, right? Well, not exactly. See, a claim that provocative is basically a dare to the scientific community. And decades later, well, they took him up on it. Using modern measurement tools and simulations, researchers set out to see if that sensitive film of his really told the whole story. So in 1983, a study in Lux magazine decided to actually measure the light, not just observe it. Their tool was something called the daylight factor, basically a way to put a real number on how bright a room is. Think of it like this. If you score above 4%, the room feels nice and clear. But if you fall below 1%, it feels dark and gloomy. Now, they could finally put the claim to the test. And the result was a total shock. The data showed that while Le Corbusier was right about some things, he was dead wrong about a really key detail. The back of the room, the part that's furthest from the window, was actually better lit by the vertical windows. Then, powerful computer simulations came along and added even more nuance. When they tested windows with the exact same amount of glass, they found the ribbon window did create a more even, uniform light. So Le Corbusier was kind of right, but it turns out that wasn't the most important thing. And here's the crucial point. The whole debate was focused on the wrong thing. It was never really about vertical versus horizontal. It was about placement. The simulations showed that if you just move those vertical windows closer to the sidewalls, the light reflects and bounces around the room, and you get performance that's just as good, if not better, than the ribbon window. It's all about the bounce. But see, this entire debate was built on one big assumption, that the whole point of a window is to get the most even light possible. But what if that's missing the point entirely? What if a window is for something more than just performance? This question takes us right out of the science lab and into an artist's studio. It makes us think about atmosphere and mood and the whole emotional quality of light. To really get this, we have to go back in time, way before Le Corbusier, to a Dutch painter who was an undisputed master of light. Johannes Vermeer. I mean, just look at his work. He wasn't just painting a woman pouring milk. No, he was painting the way that cool morning light falls across her face, across the wall, the bread on the table. For Vermeer, light wasn't just illumination. Light was the subject itself. So how did he create this magic? Well, by painting light that almost always comes from large, high windows, and get this, positioned near a sidewall. Wait a second, that is exactly the setup the modern simulations found was most effective. Vermeer understood intuitively what science would prove centuries later, that this specific placement creates these deep, rich contrasts, making everything feel more three-dimensional, more mysterious, and more alive. And this, right here, is the artist's big critique of Le Corbusier's whole idea. That perfectly even, uniform light that the ribbon window provides might be efficient, sure, but it's also, well, it's flat. It takes away the drama, the contrast, the very things that give a space character and depth. It turns out the shadows are just as important as the light. So now we have these two competing ideals, Le Corbusier's scientific performance versus Vermeer's atmospheric art. For decades, architects pretty much had to pick a side. But today, the game has completely changed. Welcome to the Modern Architect's Toolkit. Now, I know this might look like a chaotic mess of wires, but it's actually an incredibly powerful tool called a parametric script. It's what allows a designer today to analyze a window, not just for style, but for precise performance based on real-world data. This is where art meets computation. And honestly, it's not as complicated as it looks. First, you build a 3D model of your window and wall. Then, you load in a real-world weather file for a specific city, let's say Pune, India. The script then runs an analysis, calculating exactly how much sun is going to hit that window every hour of every day for a whole year. And finally, it visualizes all that data as a simple heat map. But the real power comes when you set a goal, what designers call a fitness value. You can give the computer a single, measurable target. So for a hot climate like Pune, your goal might be to find the exact window size and orientation that minimizes how much heat you get from the sun, which means less need for air conditioning. The computer can then test thousands of options in just minutes to find the absolute perfect solution. And this brings the entire debate full circle. With these incredible tools, an architect can design a window that not only creates that beautiful, dramatic light of a Vermeer painting, but also meets the tough performance standards of Le Corbusier. They don't have to choose between art and science anymore. They can actually optimize for both. Which leaves us with one last question. Now that we can design for both, what should we prioritize? What is the ultimate purpose of that hole in the wall? Is it to deliver the maximum number of lumens in the most efficient way possible? Or is it to craft a space that just gives us a magical feeling? The debate, it seems, is far from over.